so now we're going to finish up on chapter 3 by combining what we have learned earlier concerning stoichiometry with what we just recently learned concerning concentrations of solution or molarity. So basically, we can call this solution stoichiometry. All right. So we learned about molarity, what it means. It's the moles of solute per liters of solution. And therefore, we can include that where necessary, that equation where necessary, in order to solve certain stoichiometric problems where solutions are involved. All right. So this flowchart shows you basically what we're accustomed to from before. If you're given an equation which is balanced, which is, as we said before, very important in order to solve stoichiometric type problems. If we're given the mass of, let's say, a reactant or a product, doesn't matter, the first thing we would do in order to solve a problem involving stoichiometry is that we convert the mass in grams to moles for that substance. And then based on the balanced equation, we use the mole ratio to convert from moles of that substance to the moles of the other substance that the question is asking for. And if the question is asking for the mass, then we would simply multiply the moles of that substance by its molar mass to get the mass in grams. All right. Now, if we're dealing with a solution, then what we would have to do is, let's say we're given the molarity of the solution and the volume, then what we'd have to do is multiply the molarity by the volume to get the moles, and that will give you the moles of the particular substance here. Then we use the mole ratio to convert from the moles of one substance to another, and then, if the question requires, we can convert the moles of the substance to either the volume or the molarity. It all depends on what the question is asking for. So it says here, if you look at this box right here, it says we can go from moles of substance B to either volume of B or molarity of B. And they're asking how? Well, in the case of volume, you need the molarity, right? All you'd have to do is divide the moles of substance B by its molarity, and that will give you the volume in liters. And if the question is asking for the volume in milliliters, you can, of course, do the conversion to milliliters easily. Or if the question is asking for the molarity, then we can basically divide the moles of that substance by its volume in liters, and that would give you the molarity. So there are several ways that you could go depending on what you're trying to do, depending on what the question is asking for and what the question has given you, what information the question has given you. Okay, so what I'm going to do is go to an example. So let me go to this PowerPoint here. And this is an example I pulled off somewhere from the internet. I just did a Google search of questions of this type, and I just chose the first one. And I think this is a good example of a typical solution stoichiometric type problem. All right, so in this question, they gave us the balanced equation. Of course, you could be given an unbalanced equation, which means that you'd have to balance it. And then it says how many grams of silver chromate, which is this, of course, will precipitate when 150 mils of 0.500 m silver nitrate is added to 100 mils of 0.400 m potassium chromate. Okay, so the first thing we would have to do is find out which one of these two reactants would be the limiting reactant. So what we need to do first, we can start with the silver nitrate. And the first thing I would do is write down the volume. I prefer black. Hold on. Well, let me erase this first. And then choose black ink. Okay, so what I would do is start off with 150 milliliters of silver nitrate. And I'll convert that to liters. So I would have 1 liter of silver nitrate above as a numerator and 1000 mils of the same below as the denominator. Then I would multiply this by the molarity of silver nitrate, and that molarity is given here, 0.500 m silver nitrate. So this is 0.500 moles of AgNO3, and down here would be 1 liter of AgNO3. All right. So the next step is to look at the mole ratio between the silver chromate and the silver nitrate, and we can see based on the coefficients of these substances in the equation, it's a 1 to 2 mole ratio. And the way I would express that in the next conversion factor is that I would have 1 mole of Ag2CrO4, and down here 2 moles of AgNO3. And we work this out. So let me do that on my cheap calculator. 150 divided by 1000 times 0.5 divided by 2. Okay, so the answer I got here is 0. excuse me, 0.0375 moles, all right, of silver chromate, all right? So that's basically how we do the calculation of the moles of silver chromate, starting with the volume of silver nitrate. The next step is to do the same thing with the potassium chromate. Now, the question says that you're given 100 mils of potassium chromate. And just like we did before, we're going to convert that to milliliters. I'm sorry, to liters. So this conversion factor will have 1 liter of potassium chromate above 0.04, and down here 1000 mils of the same. And then the next conversion factor is where we convert the volume to moles, and they gave us the molarity as being equal to 0.400. So 0.400 moles of K2CrO4, and down here the volume, which would be 1 liter of K2CrO4. And then the next conversion factor will be the mole ratio between the silver chromate and the potassium chromate, and that would be a 1-to-1 mole ratio based on the coefficients. So 1 mole of Ag2CrO4 divided by 1 mole of K2CrO4. So again, we have to do some number crunching. 100 divided by 1000 times 0.4, and according to my calculations, this works out to be equal to 0.0400 moles of silver chromate. So what we do next is compare this number to this number, and we see that this number is lower, which tells us that it is a silver nitrate that's the limiting reactant. All right. So what we do next to find out how many grams of silver chromate that we are going to produce, or that will precipitate, is that we take the moles, the lower amount, which is what you'd expect to get, 0.0375 moles, and we multiply that by the molar mass. So you're going to have 1 mole of silver chromate down here, and the molar mass of silver chromate will go up top here. So let me see if I can figure that out on my other laptop here. So let me go here. Okay, so for silver chromate, Ag2CrO4. Okay, so according to my calculations here, the molar mass of silver chromate is 331.73 grams. And let's do that calculation. 0.0375 times 331.73. Okay, so according to my calculations, this is equal to 12.4 grams. So that would be the answer to this question. The mass of the silver chromate that you'd expect to get All right. Now, even though this question did not ask this, I'm going to introduce it anyway, or reintroduce it, because what we have just calculated here is the theoretical yield, right? That is a theoretical yield. So another question that could be asked, it wasn't asked here, but we could get a question where you ask for the percent yield if the actual yield is, let's say, I'm just making this number up here. Let's say the actual yield is 10.0 grams. All right, so let's say that's the next question that's asked. Then all you have to do is, to calculate the percent yield, is divide the actual yield by the theoretical yield times 100%, and that's it. So let me do that calculation. 10 divided by 12.4, and according to my calculation, when I multiply by 100%, the answer is 80.6%. So for this particular situation, the percent yield will be 80.6%. All right? Okay, so that's basically it for chapter 3. So the next set of videos I'm going to post will be based on chapter 4, which deals with reactions and aqueous solutions. All right? Okay, until next time.